Assalamualaikum warahmatullahi wabarakatuh and very good day. I bid to my supervisor to Teacher Noizer binti Jaafar. My name is Muhammad Ikmal bin Masa'ad, a final year student from the Department of Mechanical and Manufacturing Engineering. Today, I would like to present about my final year project entitled as a development of granular activated carbon from Akasa manganese using a chemical activation process for the water treatment application. First of all, I would like to go to the abstract or the introduction for my project. For the abstract, it is regarding the major issue in Malaysia is about the dispose of the wastewater issue as a main source for the human being. Thus, activated carbon is used as a standard material for the water purification system to clean the water supply for the domestic and the industry applications. Activated carbon, or denoted as AC, is used to filter the water pollutants such as the chlorine, organic solvent, herbicides, pesticides, and also to remove unpleasant odors and flavors from the water. In this project, Akasa mangan wood is used as the alternative raw materials in order to produce the granular activated carbon by using chemical activation process. Different concentration of sodium chloride was used in this project in the activation process in order to produce highest surface area of activated carbon. Sodium arginate also used as a binder in order to produce granular activated carbon. From the result, it shows that the activated carbon that treated with 25% of sodium chloride produce the highest surface area with the porosity of 78.5% and also with the highest ID number of 929 milligram per gram. The granular activated carbon produced is with a diameter of 1 to 3 millimeter by trapping the activated carbon powder into a sodium arginate base. From the performance study by using the methylene blue, it shows that the optimum condition for the treated activated carbon produce a reduction with the 828 milligram per gram, which is indicated that it is suitable for the water treatment application. Next, I would like to go to the problem statement. For the problem statement, it is divided into three, which is about the price, which is high production cost by physical activation process. It is also about the usage of chemical activation agent that can cause environmental issues, and also the last one is about this plant itself, that it is invasion species that can trigger other plants. So in this project, the objective is to determine the effective concentration of sodium chloride as the chemical activation agent for the production of granular activated carbon. The second one is about to analyze the surface morphology of the properties of the Akasa mangan wood granular activated carbon by using physical, chemical, and also the microstructural analysis. The last one is to examine the performance analysis of the Akasa mangan wood by using methylene blue method. Next, I will go to the experimental procedures. The first one is from the Akasa mangan tree. The stem will be cut into a small pieces. As you can see at the second graph, at the second figure, it is about the Akasa mangan woods. After that, a grinding, and a sieving machine will be conducted in order to get the granule sample of the Akasa mangan woods. After the activation process will be done by impregnated into a chemical treatment process with different concentration of sodium chloride, which is 15, 25, and 30%. After that, the treated samples will be undergo a carbonization process in order to get the activated carbon powder. And the last one is the granulation process. The granulation process is used the sodium arginate as a binder in order to get the granular activated carbon. Hence, I will go to the results and discussion. For the result, the first one is regarding to the second objective, which is physical analysis. The first one is about the bar density, and the figure 2 is about the porosity. From the figure 1, the sample that has a lower bar density than the commercial activated carbon. The lower bar density indicates that the more pores have been developed on the granular activated carbon structure. The porosity also increase as the concentration of the activation agent increase until the optimum value at 25%, but it is slightly decreased above the concentration, which is you can refer to the figure 2. For the chemical analysis, which is regarding the iodine number analysis and also the performance analysis in a figure 4, which is the methylene blue iodation study. Figure 3 shows that the result of the iodine number of the granular activated carbon treated with different concentration of sodium chloride. It is can be seen that as the iodine number increase as the concentration increase. However, it also can be indicated that 25% shows the highest number of the iodine number. For the performance analysis with the methylene blue, the methylene blue absorbance value for the sample treated with 25% of the sodium chloride was the highest compared to the other samples. Thus, it proved that the chemical activation process with sodium chloride shows a good quality of the acacia manganese granular activated carbon. For the microstructural analysis, which is can be divided into three figures, which is A, B, and C, with different concentration of the activation agent, which is 15, 25, and 30% respectively. Based on the figure 5, it was observed that the granular activated carbon bits that was treated develop a large pore size of the structure, but it is less interconnected. However, it can be seen that the different concentration of sodium chloride has a little effect on the quality of the pores produced from the acacia manganese. Thus, this is probably because only partial structure of the pores can be clearly revealed in the surface of the activated carbon bits in the SEM analysis. For the application in industry and the society of the activated carbon, it is some application which is regarding the domestic application for the water purification system. It is also in industrial application for the metal finishing to purify the electroplating solution. It is also in for the trip poisoning and overdose following the oral injection, and also the last one in a laboratory scale to purify solution. This project also related to the sustainable development goals, which is goals number 3 about a good health and well-being, and goal number 6, which is clean water sanitation. Thus, in conclusion, I can conclude that the acacia manganese treated with 25% of the sodium chloride shows the highest value of porosity, which is 78.5%, and also iodine number, which is 929 milligram per gram, which is suitable for the commercial activated carbon between 800 and 1,200 milligram per gram. Sodium alginate as a binder is successfully used to develop the granulated activated carbon with sufficient force in the surface of the granules. The SM analysis of the GAC treated with sodium chloride exhibit well-developed pores, but it is less interconnected. The performance analysis of the GAC with the methylene blue shows a positive oxidation reaction to the color of the methylene blue as it is turned colorless when treated with the GAC. And the last one, it can be said that the GAC produced from the AM is suitable for the water treatment application. Okay, I think that's all from me. Thank you so much.